So loops in Java. And I put that here twice on purpose because the point of loops is to repeat things or repeat your code. Okay? So let's take a look at our slides. So remember in our last slides I said there's 3 things you can do in Java. You can do statements, branching, and loops. We know statements, that's, you know, what statements are. Statements are our declarations when we declare variables. And then branching is what we went over the last couple weeks, our if-else statements. And then the last part of our logic is loops. So a loop is a portion of your program that repeats a statement or a group of statements multiple times, or even just more than once. An example of a loop would be to compute grades for each student in a class, and that is actually your homework. Okay? And most importantly, there must be a means of exiting the loop, because if there is not a means of exiting the loop, then you will have an endless loop and your program will pretty much fail because it'll be stuck in an endless loop. And we'll try that out today. There's 3 different kinds of loops, and this goes for any type of programming language. There's the while loop, a do while, and a for loop. And then there is a for each loop, but we don't get into the for each loops until we get into arrays. So don't worry about the. All right, we have a while loop. So then the while loop, you have your Boolean statement, and we went over what Boolean statements are, and we had it in our lab. Remember that a Boolean statement is a true or false statement, okay, using our less than, greater than, equal to operators. And a lot of times we represent our Boolean statements in a flow chart with a diamond. And I know that we had that as part of one of our labs too, was to make one of these flow charts. In a flow chart, a Boolean statement is represented as a diamond. And so that diamond will have a true arrow and a false arrow coming out of it, because a Boolean statement can either be true or false. So a lot of times we'll represent our logic in our program with these flow charts. So in a while loop, you check the Boolean statement first, and if the Boolean statement is true, you execute everything that's inside of the curly brackets after the while loop. And then after you're done executing all those statements, it'll come back up and it'll check the Boolean statement again. If it's true again, it'll execute all the statements again in order. It'll come up and check it again. And it'll keep on iterating or going through this loop until this Boolean statement is false. And when the Boolean statement's false, it goes to the end of the loop and continues on in your code. So it jumps out of the loop. It stops executing the statements, right? So here's an example of one over here on the right. Notice we declared and initialized a variable we called count, and we initialized it to 0. And then in our Boolean statement, we check to see if count is less than 100. So if that's true, then we print out welcome to Java, and we add 1 to count. Now why is this probably the most important part of our loop? Adding 1 to count. Right, so he won't be an endless loop. If I didn't have this line of code here, count would stay 0 and he'd always be less than 100, and this loop would go on forever. That's called an endless or an infinite loop. And actually, I was down in Cupertino the other day, and you know the Apple headquarters, the old Apple headquarters? You know what their address is? 1 infinite loop. You guys know that? Just thought I'd throw that out there. But so this is how it would look in the flow chart. So we have this statement translated to a rectangle right here. Count equals 0. And then our Boolean is inside of that diamond, so it has the true and the false. And if it's true, it prints welcome to Java, adds 1 to count. And that's usually how we have our arrows going back up to our diamond. And of course, if it's false, it doesn't execute the loop. Pretty easy to understand, right? All right, so here's it. What's called tracing through your code. A tracing through your code means going step by step through our code. Okay, so in this example, we are checking to see if count is less than 2. So how many times will this loop execute? If count starts at 0, you're adding 1 to count on every loop, and you're checking if count's less than 2, how many times will welcome to Java be printed to the screen? Twice, right? 1 is 0, right? And then it prints it to the screen. And then count becomes what? Count becomes 1, and it's true again, so it'll print it to the screen. And then when count becomes 2, is 2 less than 2? No. So then it'll be false. And what is count at the end of this loop? So if I were outside of this loop, after this loop, to print out what count is, what will count equal? It'll equal 2, right? Because that's when it failed. When count was 2 is when this loop was false, so when I come outside of my loop, he'll still be 2. So these trace statements kind of came with the book, but it shows you, you know, step by step how your count variable is changing. Okay. So, in order to really learn loops, what I'm going to have you guys do is actually teach you how you can write them out with a pen. So let's say we have a loop that looks like this. And we're going to use the whiteboard for this. I traditionally always use the whiteboard. It's harder in this room. So when you're first learning loops, a lot of times what you do, you guys should even bring this up here. This is why this classroom is so very good. Let's say that's our loop, okay? So let's say we have a loop like this, and when you're first learning loops, and a lot of times are when you're just analyzing loops or doing it on a test, what you'll do is you'll make a chart with all of your variables in it, and you keep track of your loop number and your variables as you go through or iterate through this loop, okay? So I'll make a little table. I'll put my loop number, I'm going to put my variables that I'm using. I'll use number and product. And this will be my first iteration of my loop, so I'll write down loop 1. And what your variables are on each loop number. So right now my product is equal to 1, and my number is also equal to 1. Okay, so actually this will be loop 0. We'll start out at 0. Traditionally in computers you start counting at 0. Okay. All right, so what you do is you see if you even can enter the loop. See if it's true or false. See if your Boolean statement is true or false. And so you pretty much plug in the numbers. So 1 less than or equal to 10. Yes, 1 is definitely less than or equal to 10. So I know I'm going to get into this loop. So I can write down what my values are when I enter loop 1. It says product is equal to product times number. So I plug in my 1 and my 1. 1 times 1 is 1. Product is set to 1. He already was set to 1, but he'll be reset to 1. And then it says number plus plus. Okay, so notice I'm staying in loop 1's row. I haven't gotten to loop 2 yet. So I just cross out the numbers and put their new values in there. Now I'll go to my next loop. And so when you go to your next loop, you'll bring down your values, what they were. And then you check your Boolean statement. You plug it in. Is 2 less than or equal to 10? Yes.
Yeah.
Okay, so then you know you jump into your loop. So you execute your statements again. Product times number is 2 times 1, now, or 1 times 2, 1 times 2. So now product will equal 2. Then I go to number plus plus, so he's going to equal a 3. And you go to your next loop, iteration. And so you plug in, you make sure you can get into the loop. So 3 less than 10, yes. Then you figure it out. Product times number is 6. And remember, we're putting it back into product. And then number plus plus. And who wants to do the next one?
Sure.
Okay, cool. Good.
Oh, man, okay.
Yay.
Let's see, product times number, oh wait.
Good. He brought down his variables because he knows he's entered the loop. Then he checks the enter loop. Yes. Good. Excellent. And what you'll start to see too when you start writing these things, he wants to do the next one. So we have count, number, and value. And count is starting out at 1. Number is the value 10. And we have, so remember that when you're entering the loop, you always check your Boolean value to see if you even get in there. And you can even think, okay, counts being plus plus, you can even think, even before you enter the loop, how many times is this loop going to iterate? If it starts out at 1 and goes to less than or equal to 10, we know it's going to iterate 10 times. Okay, because it's going to go from 1 to 10. So even before you start your loop, you can do like a little check, okay, I know this is going to iterate 10 times. Okay. So you just plug in the numbers, make sure you can get in there. 1 is less than 10, yep. And so you have an if-else statement here. And you're either adding 1 to value or 5 to value. And this if statement says if count modulus 2 equals 0. Alright. What is 1 modulus 2? So that means 1 divided by 2, what is the remainder as a whole number? That's what the modulus operator does. And just remember that when you modulus something, the remainder is always going to be less than that number. So our remainder is either going to be a 0 or a 1. So what is 1 modulus 2? 1. Okay, because it's 0, remainder 1. So 1 equals 0? Nope. So we know we don't execute that. We'll go to the else place, or else statement. And if we plug in, it was 0 plus equal 5. So it's saying value equals value plus 5. So value equals 0 plus 5. So value will now equal 5. And then we up our count by 1. And number stayed the same. Notice that we didn't change number anywhere in here. That'd always kind of be a bad idea, actually, to change both of these at the same time in the same loop. It's usually good to keep one the same. Well, anyways, practicing our table here. Who wants to do the next one? Someone that didn't do it before. This is an easy one. And so when we modulus something by 2 and check if it's equal to 0, what else are we asking it here? We're asking it if it's even. If it's even, we add 1, and if it's odd, we add 5. Whenever you want to check if something's even in a computer, you can just modulus it by 2. Here, you do the next one, actually.